This complex numbers session 25, we are going to study about application of De Morgan's theorem. Already in the part 1 we have covered how to apply De Morgan's theorem for cos theta plus I sin theta, and how to apply De Morgan's theorem for sin theta plus I cos theta. The difference is, in the first one the real part is cos and the imaginary part is sin, that is the exact part. The second one is, in the real part side we have sine and in the imaginary part side we have cos. This is not the nature. So we studied about these two and how to apply De Morgan's for these two type of problems. Now in this session 2 or part 2, we are going to learn how to apply De Morgan's theorem for a type of problem which is 1 plus cos k theta plus I sin k theta, like this. Moreover, we are going to see how to apply De Morgan's theorem. In the same way, in the numerator we have a complex number and in the denominator we have its conjugate. How to apply De Morgan's theorem for these type of problems also. Finally, in the part 3, we are going to study about simplification of a plus ib the whole power n plus a minus ib the whole power n. Now in this part 2, we have the first problem, that is 1 plus cos k theta plus I sin k theta. How to apply De Morgan's theorem for this problem? Let us see how to apply. Let us consider the problem, that is 1 plus cos k theta plus I sin k theta the whole power n. Now De Morgan's theorem cannot be applied here, because to apply a De Morgan theorem, it states it should be in the form cos theta plus I sin theta, that's all. You should not have additional number like this. So this 1 should be removed and all the other things are quite okay. How to remove this? Without removing this 1 plus, we cannot apply De Morgan's theorem. For this, do we have any formula? Yes. Since it is trigonometric one, we can apply the formula, that is 1 plus cos 2 theta is equal to 2 cos square theta. That means if we have a part like this, that is 1 plus cos something, we can write that as 2 into cos square of half of the angle. If it is 1 plus cos 2 theta, we have to write that as 2 cos square half of this angle. So we can apply here. That is, what will happen if the angle is 2 theta, then the angle will be here, it will become as theta. So now the angle is k theta. So if we apply this formula, it will become k theta by 2. Again we have another one problem, that is the angle should be same. This angle and this angle both should be same, otherwise we cannot apply De Morgan's theorem. So since it is made into half, the same should be done to this also. Is it possible? Yes, we have a formula, that is sin 2 theta is equal to 2 sin theta cos theta. It is a half angle formula. What is happening here? If the angle is 2 theta, then we can write this as 2 into sine of half the angle into cos of half the angles. So half the angle of 2 theta is theta. So we are going to apply these two formula here. So this 1 plus cos k theta can be written as 2 cos square half of this angle, that is theta. So half of this angle, that is k theta by 2. Now the angle becomes k theta by 2. So here also we must have only k theta by 2. For that we are applying the another formula, that is sin 2 theta. Sin 2 theta is nothing but 2 sin theta cos theta. Right. So in the same way, if you apply this formula to sin k theta, it will become 2 sin half of this angle, that is k theta by 2, into cos theta, that is cos of half of this angle, that is k theta by 2. For this whole power n, we have to write the whole power n. That's good. So now we have simplified the given term like this. Now if you see this term, is there anything common? Yes, that is cos k theta by 2 is here, as well as cos k theta by 2 is also here. So now we can take cos k theta by 2 commonly outside. Also we can take 2 commonly outside. If we take 2 and cos k theta by 2 commonly outside, we'll have the formula or the derivation like this. That is 2 into cos k theta by 2. It is taken out commonly. The remaining will be 2 is taken out and cos k theta by 2 is taken out. So the remaining will be another one cos k theta by 2 plus I. 2 is taken out. Sin k theta by 2 is the remaining. Cos k theta by 2 is taken out. So it is simplified like this. Now if we apply the whole power n formula, it will come to this 2 as well as it will come to this cos k theta by 2 and for this whole bracket. So our result will be 2 power n cos power n into k theta by 2 for this whole bracket, the whole power n. Now we can apply De Morgan's theorem very easily because it is in the form cos theta plus I sin theta. The angles should be same, two angles are same. And in real part we must have cos. Yes, in the real part we have cos. And in the imaginary part we must have the sine. Yes, in the imaginary part we have sine. So now we can apply De Morgan's theorem very easily. What the De Morgan theorem says, we have to bring the power inside. Just multiply these two. This plus into plus is plus. So in the result we have to put plus and we have to bring this n into the angle part. So while applying De Morgan's theorem, our answer will be 2 power n cos power n k theta by 2 into cos of n k theta by 2 plus I into sine of n into k theta by 2. So now we have simplified this problem and we have applied De Morgan's theorem. Now let's go to the next problem. There we'll have the same problem, but we are going to have the denominator, which is nothing but its conjugate. How to do this problem? Whether we have to apply the same technique or not. Now let us see this problem. The same problem, but in the denominator we have its conjugate. Whether we have to apply the same logic? Yes, we can apply the same logic and we can get the answer, but that is an easy way. See, just leave this one. If you see this cos k theta plus I sin k theta, this is a complex number, and if you see this, it is its conjugate. So if you consider this complex number as z, and we can give the name z bar to this. Now is it possible for us to link this z and z bar? Yes, because if you take modulus to this, for example, for this cos k theta plus I sin k theta, if you take modulus, we have considered this complex number as z, and if we take modulus, its result is 1. We know very well, if modulus value of a complex number is 1, then its conjugate will be equal to 1 by z. So for any complex number, if modulus value is equal to 1, then its conjugate will be equal to 1 by z. So this is our complex number. This is its conjugate. So the complex number can be written as z and its conjugate is z bar, that is equal to 1 by z. So if we apply this to this problem, it will be like this. That is 1 plus z, 1 plus, instead of this is our, if this is z, this is our z bar. The formula says z bar is equal to 1 by z because the modulus of z is equal to 1. So instead of this we can write 1 by z. Now let us try to simplify this. That is 1 plus z in the numerator. For if you take LCM, that is z plus 1 by z. Now let us take reciprocal and let us try to simplify it. Our answer will be 1 plus z into, it is reciprocal, that is z into 1 plus z. Now 1 plus z and 1 plus z or get cancelled our answer will be simply z power n. Now again, let us replace this z by cos k theta plus I sin k theta. So our answer will be cos k theta plus I sin k theta the whole power n. Now we can apply De Morgan's theorem very easily because both the angles are equal to one another, and in real we have cos and in imaginary we have sine, and if we apply De Morgan's theorem we'll get the answer as cos n k theta plus I sin n k theta. This is what the result. Right. The same way we can simplify this type of problem also. If you see here, in the real part we have sine, but in the imaginary part we have cos. Is it possible to work the same logic? Yes, you can work the same logic, because if you consider this part as your complex number, then this is your conjugate. Moreover, its modulus value is equal to 1. So according to the formula, if the modulus value of a complex number is equal to 1, then the z bar, this is z, this is z bar, that will be equal to 1 by z. So for this we can apply z, and for this part we can apply 1 by z, and we can simplify in the same way because its modulus value is equal to 1. So if we simplify it, your answer will be the same complex number, that is sin k theta plus I cos k theta the whole power n. But now we cannot apply De Morgan's theorem because the angles are same, but we must have cos in the real and sine in the imaginary. It is not so. In the imaginary we have cos and in the real we have sine, so we cannot apply De Morgan's theorem. So you can follow the session 23 model works. That is, you can take I commonly outside, or you can apply the formula sin theta is equal to cos 90 minus theta, or cos theta is equal to sin 90 minus theta. Like these type of problems, this type of formula we can apply, and we can simplify this and we can get the result. So we can apply De Morgan's theorem after making the imaginary part as sine and the real part as cos. We can apply De Morgan's theorem. Try to simplify this problem and practice yourself. Let's proceed the next session with more problems. Thank you.